Hello, everybody. This is Kawata from U Bloomington. Today, I'd like to introduce a very exciting topic of neurotrauma research happening in my lab. And let's just jump right in. So there are two topics that I'd like to draw your attention. The first one is the cutting-edge research in subconcussive head impacts. And the second one is a new collaboration is fostered around neurotrauma research. These are very interesting topics and interesting research. So buckle up, and we're gonna fly through some of that. So what we do, what we use is two approaches. One is the field setting. This is naturalistic environment of football to water polo to soccer. But that's not enough because the field setting, naturalistic setting can be noisy. So we use this control laboratory soccer heading model to safely induce repetitive head impacts. And we use diverse neurological markers, including proteomics, metabolomics, transcriptomics, microRNA and metabolites, and some of the neuroimaging techniques that we do. And also we regress against contextual factors. So I think it's important to take you around this. What's the importance of this head impact? For reference, F-16 fighter jet rolls, the pilot experiences about 9G. That's a 9 gravity force. And when you're driving your car at 30 miles per hour and it hit the brick wall, and you would experience about 40G of acceleration of the body and head. But the football and sometimes other collision sports can experience the head impact that can exceed 100G. As you can see, as the tackle hits, the head wobbles. And we can use several types of sensor to detect the magnitude of each hit, direction of the hits, and some of the strain that we can quantify using finite element modeling. And we've done a lot of research in this domain. And as I was preparing for the slide, and I was just surprised that we've done a lot since 2015 at Temple University to 2017 California and 2019 in Bloomington, and that led to current R01 longitudinal study. We published a lot. The study design is generally in the top. There's preseason and postseason, and in between we collect a lot of biofluids, some of the functional assessment to neuroimaging and before and after season. And there are too many to show, so I'm just gonna pick a couple interesting things. The first one is the cortical morphometry. This is a comparison between football players and a control. And the football player is about 100 football players, and control is about 100, and 200 to 100, so 1 to 2 ratio. And as you can see, the cortical thickness was significantly reduced in about the region of the precentral and postcentral gyrus in the football players compared to control. There was some of the cortical thinning happening in high school football players. And then we went on to test sulcal depth. So this is the depth of the sulcus, and the bigger the depth, more brain atrophy that's happening. And as you see, the red is the bigger the depth. And you see this sporadically, it's not all over the place, but the sulcal depth was increased in football players. And we conducted some of the blood biomarker research, and I just wanted to pull this data that I was working on during my dissertation under Diane Langford's lab that I love and respect so much. And so we tested this novel protein. It's called particularly interesting new cysteine histidine-rich protein. Super long, so we call it pinch protein. Pinch protein has been shown to be associated with Alzheimer's disease and frontotemporal dementia and HIV encephalitis. The function of it is when the tau protein disrupts, whether that's a degeneration or trauma, the pinch protein is upregulated and it bounds to the tau protein, the fragment, hyperphosphorylated protein. And then we apply this protein using the Western blot method. We condensed a lot, and these are the 16, this is a pilot study, 16 players. As you see on the left, it's hard to see, the preseason versus postseason of each players. Most of the players, preseason was absent of pinch, but postseason, you start to see some of the players increased of the pinch protein. And these players, with the asterisk, they had a season terminal injury early on, and they didn't play. So postseason, there was a decrease. Very interesting finding, and kudos to Diane for that. And then we went on to study season-long change in blood biomarkers. These are two proteomics, GFAP and UCHL1. The first one, GFAP, is astrocyte related, and UCHL1 is neuron related. As you see, as season goes on, from T1 all the way to T5 is a postseason, there was an increase in these biomarkers. And there was no real difference between each position group. And we collaborated with Dr. Kraft at Penn State to use the mouthguard sensor data to quantify the strain of tissue strain in the brain. And then we regressed that against change in the blood biomarkers, and we found that toward the end of the season, UCHL1 was significantly correlated with the magnitude of the strain that players experience. Very interesting finding. There are a lot to be done, but as I said, these field studies have a lot of limitation. There's something, and many things we can't control. So we use this model. This is a soccer heading model. It shoots the soccer ball at the specific velocity and magnitude and players at the ball. And we have done a lot of study in this domain. And this soccer heading model is a beautiful model, can be employed in so many different things. We've done ADHD individual versus non-ADHD and compared to, after exact same stimulus, how they respond. We've done hypoxia. We also did sleep deprivation after sleep deprived and induced soccer heading. So the combined effect, how does that happen? It's applicable to war fighters. And then we recently finished the intermittent fasting. So whether the fasting is a protective or exacerbating. But I want to point out to the new study, this is different from those four that I listed. It's that, as you know, the cannabis legalization is spreading across the United States. And the recreational use is approved in 25 states. Medical use is 39 states. Indiana is neither. But we noticed in 2020, NFL, National Football League, has changed allowable level of THC, that's the psychoactive compound of cannabis, from 35 to 150 nanogram per mil, which is a substantial change. This is to combat opioid use in NFL. Maybe cannabis might be healthier. And then this, as we expected, has been adopted to an NCAA. So right now, Big Ten to any of the NCAA, they can, it's 35 to 150. They can smoke, right? And science is diverged. Some says among 440 patients with severe TBI, this is a trauma center, after controlling for many of the key factors, the mortality rate was significantly lower for the THC positive patients, 2.5%, compared to THC negative. So the smokers did not die as many or as much as non-smokers. But others say cannabis use is associated with cognitive impairment, to psychosis development, reduced axonal integrities. But our question is, okay, football players are smoking, right? But they're sustaining a lot of head impact. Is that a good thing or is it a bad thing? Let's test it. So we partner with Dr. McKee to conduct this study. And we tried to recruit CBD users, as you see, but we could not. Bloomington campus, soccer players didn't use CBD. And so we recruited chronic THC users, that's once a week at least, use for at least 6 months. And then we induced 20 soccer headings. And you cannot believe how difficult it was to recruit control subjects in Bloomington. It was very easy to recruit the THC positive, but we have managed to hit 24 and 19. So I think that's the interesting thing about this study. But the result is actually more interesting. This is eye tracking measure. Increase means impairment. They're both group impaired at some point, but magnitude of impairment was different. Cannabis users had a lower magnitude of impairment compared to non-users. And we did a blood biomarker assay as well. As you see, this is S100B, astrocyte-enriched protein, and we restricted all the exercise effect and all that. And there was a linear increase in non-cannabis users after 20 hits, but cannabis users, that didn't happen. This is neurofilament. The change was not robust, but there was some sign that cannabis might be protective. And we went on to test in the same study. We collaborated with Dr. Blair Johnson. This is called cold pressure test. As you see, there is a water bucket, and you hook up with the EKG, and you can test the autonomic function, so sympathetic hyperactivity. So you dip your hand in a cold bucket of water, your blood pressure spikes because your sympathetic nerve is activated. And we tested at each time point. The sympathetic hyperactivity was blunted even after soccer hitting in users compared to non-users. We were so fascinated. And we went on to jot down R01, and we were beautifully rejected with a very low percentile. And I know why. I think we got too excited with this preliminary data. And I think we were biased. We were saying cannabis is a neuroprotective, but I think we should be more neutral, more exploratory. There's a lot to be done. And during this publication process, reviewers said, you should do, two reviewers said, you should do randomized control trial. And I was like, do you see our affiliation? It says Indiana. I don't know how to prescribe cannabis in Indiana, but this is CTSI, so I'd like to get a permission, so yeah, we'll see about that. So moving on to, I'm gonna make you a little bit uncomfortable scientifically. So Dr. Debbie Herbenek, a very famous sexual behavior researcher, came to me with this idea. Did you know there is a thing about strangulation, choking during having sex? It's to block your artery and airway to induce euphoria. And she's done a lot of research in IU Bloomington International Survey, and they found out 58% of IU females have experienced this choking or strangulation during sex. And 38% of female 5 times, and then 30% of young females experience this regularly. And this is one of the largest intimate partner violence. And it's because of, as you know, the 50 Shades of Grey, to the hashtag choking me daddy, to all over the place. I did not know about this, but it's real. So they came to me saying, can we do something about this? What is the real effect to the brain? So we talked to students who was interested in this type of research, and then we formed a team. And we recruited, this is a pilot study, and we recruited 20 choking, at least 4 times a month for the past 6 months, and then naive controls. And the blood biomarkers showed significant group difference. So those with the strangulation experience had increased level of blood biomarkers. This is astrocyte activation indication. And cortical morphometry shows cortical hypertrophy in the right side of the brain, and then some of the gyrification was reduced. And these participants have been chronically engaged in this behavior. We also did resting state fMRI, ALF and ReHo. So ALF is amplitude of low frequency fluctuation. It shows the power of the neural signal. And then ReHo is a region of homogeneity. How coherent is it? Left side of the brain, the choking group showed reduction compared to controls, but right side is hyperactive. This imbalance between left and right, interhemispheric imbalance of neuroactivation is related to the mental disorder. But our psychometric did not show group difference in those PHQ-9, GAD-7, and all the other stuff. So they may be susceptible for emergence of mental health. Very interesting things, and we're hoping that our next R1's gonna get it. It's gonna in 3 weeks. And after this, I have to go back to Bloomington, and we're shooting some documentary about this, because this is not United States problem. It's all over the country. So Australian filmmakers in Bloomington right now, and we're gonna talk about this and highlight. So if you have teenage kids, look this up. Lastly, I'd like to highlight a very exciting thing that I was fortunate to be part of. Dr. Chandy John and Dr. Dibida Data at Pediatric Department, and we've been collaborating for 4 years, and they are malaria, especially cerebral malaria researcher. And I'm a TBI researcher, brain trauma researcher. And then we merged a force that their research have shown the blood biomarkers were able to predict the severity of neurocognitive impairment, as well as mortality and discharge of cerebral malaria in Uganda kids. So the question is, can we establish the panel of blood biomarkers that can be deployed and used in African communities? And we successfully got R21, and I was recently there in Uganda for about 10 days and 3 weeks ago. And it was a life-changing experience, and hopefully we can expand the trauma center over there. And so this is the sky the limit in neurotrauma research. And I'd like to thank everybody who is part of this initiative and collaborator, but more importantly, the Neurotrauma Lab, my students are very enthusiastic about this research topic and the future of this research topic. So thanks for the invitation.
Hold on. Yeah, great. Maybe 1 minute for questions. I'm accounting for sort of a little bit of a delay. I see somebody maybe.
Hello, Jonah Wirt, Indiana University. I was interested in the THC portion of your talk. Do you intend on looking at either endogenous cannabinoid levels and or prostaglandin levels in these patients? As we know that in chronic THC users, because it's an endogenous system, things like 2-arachidonoglycerol or anandamide aren't produced on demand as much, and these are like things that are precursors for like pro-inflammatory prostaglandin. So
very good point. Yes, we are. I think a couple weeks, Dr. McKee has gotten P30 grant for his core about the lipid mass spec to look at the endogenous cannabinoid levels and profiling of all the circulating system. So we're going to be applying that remaining sample as well as future R01 to looking into the mechanism of potential neuroprotective or exacerbating factors. So yes. Look,
great. Thank you.
Perfect. All right.
Thank you. Great example of translation happening in both directions.